All right, lesson 8 is about graphing exponential functions. So first of all, an exponential function is a function that has a variable in the exponent. So this a value is the starting or the initial amount. This b value is called the base, and it is the growth or decay factor. And it is that b value that will be raised to an exponent, and that will make it an exponential function. If the b value is greater than 1, then it's considered exponential growth. And if the b value is less than 1, then it's exponential decay. So let's take a look at a couple of functions and identify them as growth or decay. So I have y equals 2 to the x. It's an exponential function because the exponent is a variable. That number that's being raised to the exponent is 2, so that's greater than 1, so this would be growth. Here, y equals 2/3 to the x. The number that is being raised to the exponent, 2/3, is less than 1, so it's decay. Here I have y equals 1/2 times 5 raised to the x. Again, the number that's being raised to the exponent, the 5, is the one that I'm going to look at to decide whether it's growth or decay. 5 is greater than 1, so this would be growth. And y equals 0.35 to the x. 0.35 is less than 1, so that would be decay. And y equals 5/4 to the x. 5/4 is greater than 1, so this would be growth. Now let's look at how we would graph these functions. So to graph them, you're going to create a table of values. So let's graph y equals 3 to the x. So you're going to create an xy table, and you're going to pick convenient values of x. And for exponential functions, you're pretty much going to always pick -2, -1, 0, 1, and 2. You're going to plug those values into your equation for x. So here, if I plug in -2, I have y equals 3 to the -2. So now we have to remember our exponent rules. 3 squared would be 9, but that negative sign in the exponent tells me to flip it or make it division, so it would be 1/9. 3 to the -1, well, 3 to the 1 would be 3, but then I have to flip it, so it would be 1/3. 3 to the 0, if you remember, anything raised to the 0 power is simply 1. And then 3 to the 1 would be 3, and 3 squared would be 9. Now we're going to take that table of values and we're just going to simply graph it. So at -2, I have 1/9, and we're just going to kind of estimate that on the graph. It's hard to get 1/9 very accurately on this graph. -1 would be 1/3, 0 is 1, 1 would be 3, and 2 would be 9, which is a little off my graph, but you get the idea. And then I'm just going to create a nice smooth curve. Down here, this axis here is just going to continue on and just kind of hug the curve, hug the x-axis, if you will. And let's try another one. Let's try the inverse of that. Let's try y equals 1/3 raised to the x. I'm going to do it the same way. We're going to create an xy table. I'm going to pick -2, -1, 0, 1, 2. I'm going to plug it into my function. So now I have y equals 1/3 to the -2. So if I had 1/3 just squared, that would be 1/9. But now I have to flip it because of the negative, so that'll be 9. Y equals 1/3 to the -1. Again, if it was just 1, it would be 1/3, but that negative sign tells me I have to flip it, so it'll be 3. Anything raised to the 0 power is 1. 1/3 to the 1 is just 1/3, and 1/3 squared would be 1/9. So if you notice, this table of value is just kind of the flip of the other one. If it was y equals 3 to the x, this 1/9 was all the way up here with the -2. And now we're going to graph this. So at -2, I have 9, so that's going to be up here somewhere. At -1, I'll have 3. 0, I'll have 1. And now at 1, I'll have 1/3 and 1/9. So now my graph is going to flip the other way, where it's going to get closer and closer to the x-axis on the positive side. Let's do a couple more just to make sure you get it. Let's graph y equals 4 to the x. Again, we're going to make an XY table. We're going to pick convenient values and we're going to plug them in. Y equals 4 to the negative 2. Well, 4 squared is 16, but I have to flip it, so it'll be 1 over 16. 4 to the 1 power is 4, but I have to flip it, so it'll be 1/4. Anything to the 0 power is 1. 4 to the 1 is 4, and 4 squared will be 16. Let's go ahead and graph this. Negative 2 would be 1/16, 1/4. 0 is 1. 1 would be 4, and 2 would be 16, which is way off my graph. I just kind of put it up there somewhere. And then you're just going to connect your values. Normally, I wouldn't even graph 2/16 because it would pretty much be so far off of my table. But you can see that it kind of just keeps going up and up in the air. All right, and we'll do one last one. We'll graph y equals 1/4 to the x. XY table, pick those values, plug them in. So now 1/4 squared would be 1/16, but I have to flip it, so it'll be 16. 1/4 to the negative 1, well, if it wasn't negative, it would be 1/4, but I have to flip it, so it'll be 4. 1/4 to 0, anything to the 0 is 1. And then 1/4 to the 1 is 1/4, and 1/4 squared would be 1/16. So now this would be the same exact graph, except it would be flipped the other way. Now at negative 2, I'm going to have this number 16 way up here somewhere. And then at negative 1, I have 4, and then 1, 1/4, and 1/16, and then I'm going to graph that. So if you have any questions on this, please let me know.